Hello and welcome. In Erdas Imagine 2018, we have introduced several machine learning-based classification operators. These operators can be used to classify both raster and feature datasets. In this session, we'll discuss how to prepare training data that will be used for classifying raster data using the supervised machine learning operators. Let's take a look at the raster we'll be classifying. The raster is loaded in the viewer, and it is a 4-band RGBN image and has quite a few land cover types. Some of the land cover types may not be easily distinguishable in the viewer, but some areas of the image are forested. Some parts of the image are cultivated with corn and wheat crops, and there are fallow and barren areas. There are also some water bodies interspersed in the landscape. What we want to do is to classify the pixels into these land cover types. Before a supervised machine learning algorithm can be used for classification, it has to be trained. To do so, I have prepared a training data which represents the various land cover types that occur in the landscape. So let's open the training data, which is in shapefile format. The training data is generated by manually collecting sample points from the various land cover types that occur in the image. The display does not look like it is a point data, but if you zoom in, you will see it's actually a point data. Let's fit it back to frame and also display the attribute table. The land cover type of each point sample is specified in the name attribute. While there can be several indices that can be used for classifying the raster data, let's assume for the sake of simplicity we are going to use the pixel values. With that in mind, the algorithm will be trained based on the pixel values at the point sample locations we have collected to use for training. Since the training data doesn't have the pixel values as attributes, we'll extract the per band pixel values from the raster at the sample point locations and attach them as attributes of the training data. I have created a special model that takes a point shapefile and the raster image as inputs and generates a new shapefile that has per band pixel values as new attributes. Let's load the model and take a look. The model takes the training data, which is a point shapefile, and the land cover image as inputs, and using the raster statistics per feature operator, it will extract per band pixel value for each point in the feature stream. Finally, it writes out the feature stream that has this information as its attributes to a disk. In this case, it's writing it out to a shapefile format. Okay, let's run the model. Okay, the model has run successfully. Let's open the output shapefile. I will style it by the name and also display the attribute table. Looking at the attribute table, there are now 4 new attributes corresponding to the 4 bands of the image. These attributes list the per band pixel values at the point locations of the raster. We are now done with preparing the training data, and it can be used to train the machine learning algorithm. This concludes this session. Thanks for listening.